I'm sitting between two moving objects that don't seem a lot like each other. I have a simple pendulum, which is a large mass at the end of a lightweight string. And I just have a couple of 200-gram weights hooked up to this spring. But what they do have in common is that they're repetitive. They're going back and forth. And this kind of repetitive motion is worth studying, not least because it can be used to keep time. I'm sure you know that some of the earliest clocks used pendulums in order to keep time. And the most important characteristic of anything going back and forth, especially if it's perfectly repetitive, is its period. The time it takes for a complete back and forth. So the way you find that is you pick a spot in the motion, you call it the starting point, and you figure out the time it takes to go from that spot to the other side and then back. So let's do that with this pendulum. I'll put my finger over here and I'll just say back, forth, and I'll do that for several repetitions. So back, forth, back, forth, back, forth, back, forth, back, forth, back, forth, back, forth. You could probably hear from the cadence of my voice that the period, the time it's taking for a back and forth, doesn't seem to be changing. It seems relatively constant. Is that true over here? Well, I'll try that. I'll start with down. So down, up, 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 down, up. It has its own period. Time to go from down to up and back to down. It's different than the pendulum. In fact, we're going to see every pendulum and every mass on a spring has its own unique period. And that's what we're going to start investigating in this unit. What factors cause this? These are both types of a very interesting type of repetitive motion called simple harmonic motion. It results from a very specific relationship between the force used to make something come back to where it was and the location of where it is. And believe it or not, these two objects have that rule in common, which we'll discover in the course of this unit. So our first endeavor is going to be to study the simple pendulum. Then we'll look at mass on a spring. And then we'll look at a few other types of simple harmonic motion and see what they have in common.